Good evening, and welcome to Chapter 10. In this chapter, we're going to continue what we've been doing with geometry, and this chapter is going to boil down into nice even thirds. There are a total of 9 lessons in Chapter 10, the first 3 of which are going to be the areas of two-dimensional objects. We'll talk about rectangles, parallelograms, trapezoids, triangles, and circles. We'll talk mostly about their areas. We'll talk a little bit about perimeters and some other things too. The middle third is going to be talking about the surface area of three-dimensional objects. We're going to talk about basically 5 main categories. We're going to talk about cones and cylinders that are based on circles. We're going to do prisms and pyramids, which are based on polygons. And then we're going to do spheres, which are also based on circles, but circles that are spun rather than raised up. And that'll be the middle third, and we'll talk again. We'll focus on surface area for that section. And then the last third, the last 3 sections of this chapter, we're gonna again focus with those same 5 three-dimensional figures, but we're going to focus on the volume of those figures. So again, 3 lessons on 2D area, 3 lessons on 3D area, and then 3 lessons on 3D volume. Okay, so that's a quick look ahead at Chapter 10. So let's jump right in and get started with the area of a parallelogram. All right, now remember, when we talk about the area of a parallelogram, it implies that we're talking about the area of everything that is under parallelogram in the quadrilateral diagram. So when we've come up with stuff that's true about parallelograms, it's also true for all rectangles, it's also true for all rhombuses, and it's also true, or rhombi, it's also true for all squares. Okay? So we'll talk about a general formula for the area of a parallelogram, and we'll talk about some of the more specific ones. Before we do that, let's talk, I know we all kind of have this notion of what area means, but let's make it very formal. Okay, the area is the number of squares, I should put a plural there, it's the number of squares, no, actually I was right the first time, it's the number of square units a figure encloses. Okay, so let's just start with a very simple rectangle for a second. Okay, so if I have a rectangle that is 2 units by 4 units. Okay. I could literally think of that broken into grids. Okay, so let's go ahead and break the 4 into nice even parts. And sure enough, if I lay down 2 tiles by 4 tiles, you can very quickly just count. There's 8 tiles there, regardless of how big they are, whether these are square inches or square feet. We get the notion of the filling up the space. Okay, and that's really what an area is. Now, for a rectangle, rectangles are very simple. Rectangles have nice right angles, and so for a rectangle, the area of a rectangle is just the length times the width. And you've seen that formula before. Okay. Now, with a parallelogram, parallelograms tend to be leaning over a little bit, and so what we have to do with a parallelogram, we have to be a little bit more careful. We do use one of the sides. We're going to call it the base. It's basically the same idea as the length. But instead of using the slanty side here, okay, I'm just going to put a question mark there because we don't use that at all. What we use instead is we use the height. And the height has to be perpendicular to both of the parallel lines in a parallelogram. So whichever side you make the base, the height has to be perpendicular to it. Now, let's draw the exact same parallelogram, and this won't be perfect. But I could allow for this. Let's change colors too. Okay, I could allow for this to be the base, and that's fine. But if that's going to be the base, then the height is going to have to go down perpendicular like this between the 2 parallel lines on the side. Okay, and if I do this, this base times this height should give me the exact same area as this base right here and this height right here. Okay, so let's do a quick example. So suppose on this the area, we're going to find, oh here, let me back up for a second. Okay, let's say that in this one that the base is equal to 6 and the height is equal to 4. So what I do is I just take a simple formula for the area of a parallelogram, which is just the base times the height. So the base is 6, the height is 4, we multiply those together, we get 24. If we don't know what the units is, or what the units are, we always put units squared to indicate that we're talking about square tiles like we saw in the previous slide. Alright? Now, if I come over to this other parallelogram, let's say that in this one, that the height here is 6 and the base is 4. Alright, so the area now, the base is 4, the height is 6. All they've done is really switch places. Again, I'm going to get 24 units squared. And it doesn't matter that I'm using a different height and a different base because we're still talking about the same area that the 2 parallelograms take up. So don't get into this habit that the base has to be a horizontal side, or that the base has to be on the bottom. As we'll see, for a lot of the figures that we'll see in this chapter, very often we think of things leaning over, and so the base can be any side that we want it to be. All right. Now, another thing that you can do with these simpler formulas, and again, remember that these, since this is true for a parallelogram, it also works for a rectangle, it works for a rhombus, and it will also work for a square. Now, we do have a specialized formula for a square. I'll just jot that down quickly. In a square, first of all, the base and the height are just the basic sides because they are already perpendicular to each other. And furthermore, the base and the height are both the same thing. So the area of a square is just sides squared. Okay, just like we saw the area of a rectangle, okay, was equal to the length times the width. Okay, so we do have some special formulas for some of the other figures. All right, let's go ahead and take a look at a figure like this. And this is how we actually apply these skills. What I recommend that you do for a figure like this is imagine that the figure is one big parallelogram, or in this case a rectangle. All right, we know from here to here, from the top being 8 feet, that this is 8 feet. And from over on the left side, we know that the left side is 4. So without the little holes, let's say this is a patio, and maybe in the middle we have a little fountain, and then there's a little cutout in the corner. Without those little holes, the area of this rectangle is just base times height, or length times width, it doesn't matter. We get 8 times 4 equals 32. And again, it's going to be units squared, but we're not done yet, so we don't have to put the label in. Right, then what I'm going to do is I'm going to subtract the pieces. So this little square here that I'm going to cut out has an area of 2 by 2, so it has an area of 4 square units. The one down here, because this whole length here is 4, and we know that the pieces here are 2 and 2, and we know that, actually I think this 2 is referring to this part here. So this is 2, 2, and 2. So the piece missing right here will make it yellow. The yellow missing piece is also 2 by 2, so that's also 4 units. So right here we've got a total of 8 units that have been removed. So now just subtract 32 minus 8 equals 24 units squared. And that would be the area of the tan patio, or whatever it is. Okay? That would be this part right here. Okay. Now, there are other ways to do irregular shapes like this. You could break it up into individual rectangles, find the different pieces, and then add them all together. It is almost always, like more than 90% of the time, easier to find the total area and then subtract out the pieces. Just the way that these things tend to be drawn in math textbooks. Sometimes it's the only way to do it. Very often it's the easiest way to do it. All right, we're almost done. I don't want to make this video really long. What I'd like you to do is go ahead and pause the video for just a moment, and I'd like you to apply the formula area equals base times height, and I'd like you to just quickly find the area of these 3 rectangles. Write it down on something, a piece of paper, a scrap piece of paper, your notes, whatever. And as soon as you're done, go ahead and hit unpause the video and just check to see if your answers match our answers. And I will warn you, there are some extra numbers in here, so be very careful about your base and your height when you pick them. All right, pause the video now, please. Okay, if you follow directions on this first one, you're looking for the base and the height. And again, the base and the height have to be the base has to be one of the sides. We have 5 and 6, but we have the 4 perpendicular to the 5. So that's what we're going to use for the base. And I should have put the little box in there. I apologize for not including that. So base times height is going to be, and actually let me back up. It's a really good habit to get into rewriting the formula. So area equals base, sorry about that, equals base times height. That way I know what you're putting in for what variable. So that's equal to 5.4, no big deal, which is equal to 20 units squared. And there, for just a little tiny bit of extra effort, I've shown all of my work. And so there we go. So you should have had 20 units squared for the first one. The second one, be very careful. The base is going to have to be this side over here. And if you extend the base out, you do get a height coming down to the line that contains that 3. So this one is going to be area equals base times height. Again, notice rewriting the formula. The base is 3, the height is 4. This comes out to be 12 units squared. And then finally, the last one, let's go back to the green. Okay, in the area for this one, since it's a rectangle, we can do base times height, or we could just as easily substitute length times width, which is 3 times 8. 8 times 3. By the way, it doesn't. There's no rule that says length has to be the long one and width has to be the short one. They're completely interchangeable. They're just the two sides. And so 3 times 8 is 24, and again, we always label area with some sort of unit squared. Now, if any of these problems had indicated that we're measured in centimeters, or kilometers, or feet, then that would be the unit squared that we would get. You can use u squared, as I did in the red, or you can use un squared, as I did in the yellow and the green. Okay, so that's what you should have got for your 3 practice problems, 20, 12, and 24. I hope that worked out for you, and I will see you in class tomorrow where we will continue to practice area of parallelograms. Thank you very much. I look forward to a good chapter with you all.